Alright, so in section 7.2 we're going to discuss rational exponents. The idea with rational exponents is right here. The key idea is the word ratio. A ratio is a fraction. And so we're going to be looking at fractions in exponents. Okay, so x to the 2/3 power or x to the 5/8 power or something like that. So some sort of fraction in the exponent. Before we do that though, I want to go back and just review some of our basic exponent rules just for a few minutes. Okay. And these exponent rules we looked at quite a bit back in chapter 1. Very beginning of the semester. It was kind of a review topic, so I'm hoping this is not new to you. It shouldn't be new, and that you pick up on these things very quickly. But we had several exponent rules, one called the product rule. And the product rule is where you had, if you had two exponential expressions multiplied together, then you add the powers together. So here you'd have x to the 7th. Okay, if the bases are the same. Sorry. Quotient rule is similar, but using division. So if you had something like x to the 8th divided by x to the 5th, you subtract the powers and you get x to the 3rd. Okay, so the product rule, you add the powers. Quotient rule, you subtract. We also saw, let's see, the 0 power rule. Which basically said anything raised to the 0 power is equal to 1. We saw the negative power rules. And there's 2 of them. If you have anything raised to a negative power, then we can move that base to the denominator with a positive exponent. Or there's another one that says if your base is already in the denominator, you can move it to the numerator with a positive power. And of course I'm using 1 there, but it can be any negative number, -5 or negative anything. So these are just examples, not the actual rules written out. We also had the was it the power rule, which is where if you have x to the 3rd raised to the 4th, a power to a power, you multiply those powers, you get x to the 12th in this case. Okay. We also had product to a power. Oops. Product to a power. And that would be if you had like xy raised to the 5th power, then both the x and the y get raised to that power. And finally we had the quotient to a power. And that's where if you start off with a fraction raised to a power, then both the numerator and the denominator get raised to that power. Okay, so we've seen all of these before. There should be nothing new. I just wanted to refresh those. Now let's go back and let's start talking about fractions. Now I did all of these with whole numbers, integers I guess, because there's some negatives in there and 0. But we can also now start putting fractions in. But we need to know what fractions represent. And so let's start with the basic one. Let's start with a 1/2 power. And so the 1/2 power. So what better way to explore the 1/2 power than by raising something to the 1/2 power and seeing what happens? So let's start with an example. Let's look at something like x to the 6th. And I'm going to raise that to the 1/2 power. Well, x to the 6th raised to the 1/2 power is the same as x raised to the 6 times 1/2, because notice a power to a power using a power rule is the product of the two powers. So we've got to multiply them together, which of course is x to the 3rd. Okay. So then the question is, well, what else could we do to x to the 6th to get x to the 3rd? And well, if you think about it, going in reverse, if we go in reverse and take x to the 3rd and raise it to a power, what power would I need that to be to get x to the 6th? Well, the answer is a 2. Right? You would need to raise that to a 2 power and then multiply the 3 and the 2 to get the 6. Okay? So essentially what we're doing is, if the reverse of a 1/2 power is a square, then the 1/2 power and the square must be sort of inverses of each other, or one must undo the other. And we already saw that happen back in section 7.1 with a square root, right? So the 1/2 power and the square root are the same. Okay, the 1/2 power and the square root are the same. And we can prove this in other ways, but I just chose kind of a nice example just to motivate the idea. Okay, so essentially, if I have a number like 9 raised to the 1/2 power, well, that's exactly the same as just the square root of 9, which is 3. And of course, we'll use the principal square root here, assuming everything to be positive. If I had, let's go with, let's say 25x to the 10th power, and I raise all of that to the 1/2 power, well, according to our product to a power rule, each of these factors gets raised to the 1/2 power. So it's like 25 to the 1/2 power times x to the 10 to the 1/2 power. And if we take 25 to the 1/2, that's really the same thing as the square root of 25. And here I could just multiply these. I don't have to write it as a root. 10 times 1/2 would be x to the 5th. And of course, the square root of 25 is 5, so this becomes 5x to the 5th. Okay. All right, so you can see if there's a number here, like a coefficient, you take the square root of it. If you have x to the 10th, a power, you take half of it. And now we've dealt with, in the last section, the idea that a square root could both be positive or negative, but we select the principal root unless otherwise stated. So if I put a negative in front of the root, I'd want to use a -3 answer, or a negative answer. Well, we're going to assume at this point that everything is positive. So for this section, assume all variables are positive. If we don't make that assumption, we could end up with some weird things where if you take a square root of a negative number, you end up with something that's not a real number. And so we don't want to deal with any of that, so we're just going to make this assumption, And in your homework on my math lab, you're also going to see this actually written in the instructions to assume all variables are positive values, and that allows you to ignore the idea of having to write absolute values for your answers. Okay. In the next video, we'll take a look at some more examples of what you can do with radicals.